Okay, gang, we're going to do analytical limits here. And the idea with an analytical limit, as long as it's not a domain restriction, the plug and chug value will give you the same value as if you were looking at it and seeing what you were approaching. It's the domain restriction that's really an issue. All right, let's just go over some real basic ones. If you take the limit of a constant, so let's first of all think about that for a minute. If you have a function that's a constant, let me give you a for instance. Here's a function that's a constant, y equals 7. So if I draw y equals 7, that looks like that. And it really doesn't matter what x value I'm at. Let's say I'm at x is 3, and it's two-sided, so I'm coming at 3 from both sides. Coming in from the right side, I'd be at this height. Coming in from the left side, I'd be at this height. Right? So I'd be coming in at the same height. So it doesn't actually even matter what x value you're at, because the limit will always have the same answer no matter where you are, because the height is always the same. So you're always going to approach 7. So it doesn't even matter where I am. The limit of a constant will be a constant, because the only output, the only height that this graph can offer is a 7, no matter what input I'm at. So that's what this is saying. If you have a constant, the limit of a constant is a constant, because that will be the only height on the graph. Okay, so that's our first rule. Now this function, do you remember this guy? What this function is? This is the identity function. The identity function is when y is equal to x. So if x is 3, so if x is 3, then y is 3, right? Because y has to equal x. If x is 5, then y is 5. And on and on and on. So whatever x is, that's what y is going to approach. Whatever x approaches, y is going to approach. So it's an approaching concept, right? As x approaches something, what does the y approach? So for this one, since x and y are equal, whatever x approaches, that's what the output is going to equal. So like if x approaches 3, then the output approaches 3. So what x goes to and what y goes to are going to be the same value on the identity function. Okay? So for the identity function, whatever you put in is what you get out. And this one is it has an exponent on it, and it's as simple as just plugging in. There's no domain restrictions on this. So whatever you plug in for x, that will be the y value it's approaching. Oh, I didn't actually realize this was a 7 going to 3. Okay, I should maybe play the lottery tonight. All right, so remember, the limit of a constant is a constant, so this is a function, and I don't know how I did the one right there. I must have knew it in my head or something. Right, so as I go to 3, this is going to go to 7. So this guy's going to go to a 7. Now here's the identity function, the y equals x function. So the limit of, if you plug in -5, as x goes to -5, the height is also going to have to go to -5. Right? As x goes to -5, right, as x goes to these values, its corresponding heights are going to also go to -5, because what you put in is what you get out on the identity function. And you're just going to learn as we go through this. It's as long as it's not a domain restriction, the function will approach the plug-in. And I hate to use that word because then people tend to think this is like intermediate algebra, but the function, as long as you're not on a domain restriction, will approach the plug-in. So meaning like -2 to the third, that's -8. So if it's something that doesn't have a domain restriction, you can go ahead and plug it in. There are a couple exceptions, and we'll go through those. But more of the more basic functions, you have no worries at all. Okay, let's see. So you can sort of stop the video and look over these, but the majority of what this is saying, and I can go through the gist of it, it's mostly just you have to watch the domain restrictions and that the basic algebra works on these functions. So meaning if you're multiplying something times a function, the limit gets multiplied times that value. If you're adding or subtracting functions, then that's the limit of adding and subtracting those functions. It's just doing the algebra of the function. So here, let me give you, for instance, you see this is like, has 3 parts. Since this is a polynomial, it has no holes, no gaps, it's continuous. That would mean that the limit as x goes to 1 would be the same thing as what it is if you plug it in. Right? Because this is continuous, so it will approach the same value. So this will equal to 5. So whatever this graph looks like, as x goes to 1, the heights from both sides will approach 5. This is a parabola. So if you're having trouble understanding all the rules and stuff like that, the idea is, the most basic way I can say it, is you're just literally going to plug that value in. In general, that's how you do analytic functions. You have to watch the domain, and there's some exceptions, and I'll go over that. Let me just do some more. This should seem like real basic to you, hopefully. So some problems in your book will look like this. So we know if you have a cube root, the domain of that is all real numbers. So if I plug in chug, it's going to actually give me the limit. So if I go ahead and plug in the 2 here, cube root of 27 is 3. So the limit as x goes to 2 of this function is actually 3. Okay? So the golden rule is you can plug in as long as you're being sensitive to what the domains and the special cases are. Now there's a fraction you can't divide by 0, so as long as I'm not putting in a -3, I'm okay. That would be like a problem area here. So I'm putting in a -5, so I'm fine. So if I put in a -5, I have 5 over -5 plus 3, which is 5 over -2, and you can just leave that as an improper fraction, that's fine. Or you can write -2.5, any of that's fine. So the golden rule again is that I can plug in, because this, as x approaches -5, the y value will actually approach -5/2. So you'll notice for a lot of this homework, the parts that I'm giving you for the weekend, these are just very straightforward. You're not going to have any issues with this first part. You're just going to plug these x values into the function, and that will be the correct limit. You'll be approaching the correct height on all of these. Now this here, I'm not sure if you guys remember how to do this. I feel like for the first part you'll be okay. You plug a 1 in for x. On the f function, you plug a 4 into g on the g function. Now this is a composite. So first you have to plug f function into the g. So you literally have to stuff 5 minus x into the x cubed. And then after you stuff it in there, then you plug in the 1. So these are composites when you do 19 and 21. If you get stuck on them, email me and I can make you a little video. Okay, now over here, these are the ones that are worrying me a little bit because there's so much pre-calculus in calculus. So let's just take a moment here and talk a little bit about these. Let me see. Okay, this is I'm already at 9 minutes, so let me start this in the next video because I want to take a little time to help you with your trig. Okay, so let's end this one here. So in this video, we just started talking about how you do an analytical limit, and we talked about the golden rule is that you can plug in, and we went over the rule that the limit of a constant is a constant. So that was really the only sort of different than the others that I've done so far. The other ones you could have just plugged in. That one's plugged in. And I just started some basic examples. Okay, so let me end that here and I'll go through the next video. Catch you.